Welcome back to my channel. Today, the subject we are going to discuss is, are we trying to compare and unify the Apple of Gravity with Graviton, let's say, Graviton with the Orange of Photon? Uh, it may sound very just what do you call, not logical, but just word play. It's not word play, actually. In the last video, it's not literal. The meaning is not literal. It goes beyond that. Last time, I explained about this. It's the quantum world. Yeah, let's say this is relative realm. In the quantum realm, I started with 10 squared, 10 raised to 4, 10 raised to 6, and overall it was 10 raised to 8. Here we started with c squared, c cubed, and we ended with taking another c4. Right? This is rather 81 into 10 raised to 32. See, this is rather 3 into 10 raised to 8. See, right? I said this was the first dimension, this is the second dimension, this is the third dimension, and this is the fourth dimension. Right? Similarly, first is equal to fourth of quantum, second second dimension, third dimension, fourth dimension. And so um, the thing is, this is entirely different. Let us now take the dimension, then the what do you call, magnitude, then we will take rather this is for quantum, this is for relative. We will compare both magnitude, force or field, and here uh, we had force field and the force carrier. Same thing for this magnitude, for force, the last one being force carrier. First dimension we took. Magnitude we took was 10 square. Magnitude for relative we took was C. Force that is associated with this, I told you, magnetism. And for this, though we don't have one uh, force carrier, I told you I call that magneton. And then we have C, the force being the light uh, energy, rather energy. Uh, this being light, this being force carrier being photon. Right? Second dimension we went to 10, 10 raised to 4. Here we had here we had uh, QE equal to 1 by 4 pi epsilon naught Q1 by Q1 Q2 by R square, 4 pi R square. When we say this equivalent geometry also, we will provide geometry, geometry. This was 2 pi R, right? This was 4 pi R square and 10 raised to 4. Here, this was actually the QE equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Let us leave this thing for present. Here we took C square and geometry also will include. Geometry will be naturally 2R, uh, 2R basically. 2R is the diameter of this circle. If first we start with this circle, this is a circle, only 2 pi r. Then we go with this circle. This is the pi r square. 10 raised to 4 is equal to pi r square. And then we go for 4/3 pi r cube. That is this whole sphere, let's say, the whole sphere, including this length. So that is 4/3 pi r cube. So third one, okay, yeah, light. And here the equivalent force was, um, let's say, flux of which is flux of gravity. Let us say flux of gravity was 1 by 4 pi r squared into 119 uh, mm. Instead of g, we are substituting this value instead of g by r squared, right? So this 4 pi r squared, we are dividing with that 4 pi r squared. Even here, we are taking the what do you call spherical. This model includes both spherical and cubical. This includes only cubical as yet. Now, third one, we took 6 pi r, uh, 6 into 4/3 pi r cube. This was 10 raised to 6. And this was, I told you, this was mass. Right? This is the flux. This is the mass. Gravitational. Sorry. I'm sorry. I'm sorry. I'm one step ahead. Okay. So this is not. This is charge. right? And then here we took CQ in its place. See, this is 2R, this is 2R square, this is 2R cube, kind of. And what was the charge? Right here, uh, this is the third one is charge. Here it will be mass. CQ is mass. And fourth one we went to, and we got 2 pi r4 10 raised to 8. This was basically photon. Photon. This was basically electromagnetic radiation, or represents photon. Basically, yeah, it should come here. Here, photon. The energy force carrier is photon. Here we had C4, and it 2R raised to 4 whatever. And then we had the relative equivalent of EM radiation. Here, this is gravito photo radiation, I call it. Okay? And what was the force carrier for this was for mass, the force carrier. For this, the force carrier was graviton, will be graviton. Okay? Yeah, that's it. For there is no force carrier here. This is the particle. This is the particle. There is no force carrier. This was what we basically thought. I so far we covered so far. The same thing happens here. Uh, this is C. C is corresponds to 2 pi r. This whole thing is 4 pi r squared, like um, c squared. C squared corresponds to the area. This whole thing, again, when you join this whole thing is 4 pi r cubed. Again, same thing for both. Corresponding, what I mean to say is the corresponding geometries for both uh, worlds, relative as well as quantum, were same. Both are same. Quantum realm, the relative realm. Only thing that changed was this magnitude, 10 square. Here it is 10 square, here it is C. And this C is the fourth dimension of this quantum world. That fourth dimension became the first dimension of this relative. So, so the big question here is: is the are we comparing? As you can see, I will explain a little bit further. Only then you will understand the scale of these two worlds, right? One is of we all know Planck scale, quantum world, and the other is of at least minimum of our solar uh, solar system. If we look down from Oort cloud, beyond Oort cloud, on the our solar system. What our solar system looks like is what quantum system looks like from our world, right? So now, uh, this is it's been always my favorite subject, Pascal's triangle. Don't mind uh, telling the same thing all over because it's so important, right? This is 11 is to 0 equal to 1. This 11 is to 1. This is 11 square, 11 cube, 11 4 times raised to 4, 11 raised to 5, 11 raised to 6. And here I told you about my chance discovery that Planck's constant h equal to m 119 by c. This m is 1.67 to 637 minus 27 into 119 by 3 into 10 raised to 8. This gives me approximately 6.062 into 10 raised to 34 joules units. Uh, don't bother about units, but this is what my chance discovery was. So in this discovery, what did we find? This 119 is pretty much close to 11 square. So I associated this with 3 into 10 raised to 8. If this is C, which is C square, which is C cube, C raised to 4, C raised to 5, C raised to 6. And this will be root of C, this will be fourth root of C, kind of. Don't bother about the, I mean, you can bother because we are taking root C, so even root of 3 will also be counted, fourth root of 3 will also be counted. This comes to what? This will be equal to something 1.712 or something to 10 raised to 4, right? And this will come to, I don't know, 1 point something into 10 raised to 2, isn't it? So these were the correlations I had. And so the similar way, there is, you know, uh, there was one scientist called Christian Huygens. He was a Dutch scientist. I too had some, I have connection with the Dutch because I worked there for 3 years in Amsterdam and Utrecht. I worked for 3 years. So I have Dutch connection, and whenever I see a Dutch scientist, I feel good. This guy is Huygens is a Dutch scientist, and one more wonderful scientist from Holland was our Lorentz. Henrik Lorentz was another scientist. Henrik Lorentz, by the way, is the father of relativity. Basically, he started relativity. He came up with transformations, but Einstein perfected them. Like Maxwell's equations. See, relativity is built on Maxwell's equations, and um, Einstein built general relativity on Maxwell's based on Maxwell's equations and principle of equivalence of variable. So Einstein was such a genius that he put everything together, all the science before him together, and he came up with one master stroke of C4. What was that master stroke? We will come to it probably. Let me go down quickly. Mu is equal to 8 by G by C4 into P mu. So that's what he came up with. This C4 in a kingpin. This C4 rules everything. Bit from here to here to see this is the relative, and from here, from C downwards, these three is our quantum. So this C4 is at the top of these six dimensions. So that's what he did for Albert Einstein. Christian Huygens came up with one theory called by Huygens law, actually, basically. What it says is every wave front acts like uh, origin for further waves. And these waves uh, interfere with each other and produce next wave front. In a sense, if you have a wave like this, it, it comes out of a slit, it comes out of a slit. These go on interfering with each other, and every point on this front, you can form a front by taking tangents all along. You can form a wave front, and this front acts as a new source of wave. Again and again and again, they go on forming the wave. So, what was, yeah, so that's fine. And then, I mentioned Huygens is Huygens uh, law works well for odd number dimensions, odd dimensions, but it fails for even dimensions. See, are you getting the point? I hope you are getting the point. So, let's say, uh, yeah, it works well for, these are rather confusing. It works well for this. We all know this electromagnetic radiation is a wave, right? So it works well for this. It doesn't work for this. This correct. It works for this. It doesn't work for this. It works for this. It doesn't work for that. Similarly, downwards also. So it works for this. So it doesn't work. It works for what? 11 raised to 0. Or in terms of it is times square, right? Because 4th root of c is a times square. But root of c is damaged to 4. So that's a weird thing, but yet If you take, basically, you take, right, this wave, um, this was wave, this was particle with wave. So we will take with wave. Wave is represented by cube or square here because this is just two dimensional. And then we take one more. There is one more circle over there describing that, and there is a circle describing that. There is a cube describing that. There is a circle describing that. This is fourth root of C. This is the root of C. This is C. This is C square, C cube, C raised to 4. It is C raised to 5, C raised to 6. That's it. So basically, this is a wave. All the squares here, this one, this one, this one, this one, this one, all waves. Squares equal to waves. Spheres equal to particles. And as I told you, this was what I discovered in the, yeah, let us keep this probably because that will be that will give you a chance to visualize properly. All right. So the lines comes. Yeah. So it works well for this items. For this, what happens is here I uh, got that H equal to 190 m by c. When you come to this, it becomes mc square. E equal to mc square. Here E equal to m by c. Again it repeats. So naturally it repeats. And for this, when you come here, what it will do is energy is equal to this was 11 squared, right? This is 11 squared. This will be 11 raised to 4. 11 raised to 4 into sun is this, the 2 into 10 raised to 30, which is weight of our sun divided by C4. Because these are repetitive phenomena. This phenomena, again, of course, some other equal to in terms of mass again into some c raised to x it will be. So okay, we are bothered about only this part because we are bothered about above all gravity, right? When we talk about general relativity, it's all about gravity. So this will be that will be like E equal to 11 raised to 4 into 2 into 2 raised to into 0 into 10 raised to 30 kg by C4, which gives you around 3.651 or something joules or something. That's not important. This formula is important, right? So, as I told you about the fourth dimension here, let's say C4, C, this is C2. C cube C, when you take the cross product, you will get C4, and that C4 is a pair. Again, 11 squared, as was 11 squared, so will be 11 raised to 4. And what we need to note here is that it was C here, and this was C. Okay, yeah, this was C. Right? Mm, the lowest one is fourth root, second root, and this one. Yeah. So this is C. This is C. So this C is equivalent to C. But if you observe, though this is like a wave propagating, this wave is basically propagating downwards. It started with, let us say, when we take 10 raised to 32 C4, C4 goes on uh, dividing into smaller 10 raised to 32, 10 raised to 16. This divides into uh, again 10 raised to 8. This divides into 10 raised to 4. That divides into 10 square. Let us stop here. Okay. So that is the way here. Goes on splitting until it reaches C. Let us say this C is the border of the uh, um, border. Let us say border of quantum and relative physics. This C. So it broke down till C. This is C. This is C4. Now you get the comparison of scale. Right here, the scale, if you take scale here, C was still here, the C4 is still there. If you take the comparison of scales. So this is the quantum level. This is the relative derivatives here, that not here, just till here, let us say. Till here, it is the relative. So, though in figure this is not to scale, our figure is not to scale, so you can't even imagine the difference in the distances and the scale of these objects, objects and particles and whatever. So, this C is of the order of Planck's order. What is Planck's order? 10 raised to minus 43 or something. But I'm not really sure. I have to check this. I have to keep checking facts before telling you. But then, yeah, it's around minus 43 or something. Planck scale. This is the Planck's order. See, what is this scale? That scale is the mass from you can guess the mass itself, while the uh, kg kg. If this is proton, this is sun. So sun is about equal to 60 times proton. The weight of sun is 60 times the weight of proton. So you can imagine what will be in terms of distance, angstrom units. In fact, angstrom units, it is so big, so big. So now coming to the actual subject of the I'm going to talk. So if you want, you can pause the video and go back and zoom and see whatever you want to see. Okay, but I hope you understood uh, my concern here. Now, uh, next thing. Next thing, we will see what exactly graviton is. Just now, I have told you, just 5 minutes before, I think, I told you what graviton is, of course, according to graviton. What is graviton? Just now I told you C square P C4 equal to C4. Um, this is yeah C4. As I told you, Planck's constant is equal to 195 C. Similarly, graviton is invoked in. This was Planck's constant. This I called Russell's constant. Let's say is equal to 11 raised to 4. This was basically split was 11 square into mass of proton by speed of light. This will be 11 raised to 4 into 2 into 10 raised to 35 C4. So if on the here, let's say, if you draw the lower one, this is C is 3 into 10 raised to 8, 10 raised to 8 as what photon is to quantum. Graviton is to electron. So here this was Planck's constant, meaning photon. This was photon, right? Each photon is this much. So this is graviton. This is graviton. So now, as I explained just now, are we comparing gigantic graviton to minuscule minuscule photon? That's the big question I have for you. If so, does it make sense? Does it, I mean, it may come as bad news for many two specialists, right? There's at least few thousands of people working on Tau right now. I've been working on Tau for past 120 years, 100 years at least. Um, yeah, after the hangings and Dr. Weinberg of the Salam's weak electro theory and on and on. You all know that. You are really into this, know better than me. So, but my question is to you is, does it make sense? Does it make sense to compare the apple of gravity, literally Newton found gravity by watching an apple fall to ground, right, from tree. So you can as well compare gravity with the apple. What's this? Or this is graviton. This is, I mean, I'm not saying you're trying to just combine these two, but the rest of the debt is with this photon, and it is equally small on the Planck's in Planck's proportions. This is in Planck's proportions, right? The whole of quantum world is in Planck proportions, whereas this is in very uh, at least minimum of solar system, our solar system, size of our solar system is what this gravity is concerned with. Just now I gave you the value uh, graviton is equal to 11 raised to 4 into 2 into 10 raised to 30 by 10 raised to 32 C4 is equal to, it works out to 3.6 joules or something. Whereas Planck's constant H equal to 190 m by c, which is my language, you can actually take actual value into minus something. So how many times this is this into x equal to less? 6 point, let us say, take roughly 6.6 divided by 3, 2, let's say 1.75, 1.8, let's say, into not 1.7. This will be 36, 60, meaning around around uh, 36 by 6 is let us say 5.8 or something into this is 10 raised to minimum of 32 times. I mean, this is rough, very rough, very rough. Don't go by this, but I just want to give the this number. It's around 10 raised to 32 times graviton is the photon. 10 raised to 32 times the photon. If what I tell you is correct, probably, of course. My definition of graviton holds, then definitely it is 10 raised to 32 times uh, more than times the photon, right? So I think, of course, anyone with any little uh, intellect would say it is ridiculous, right? But who am I to say it is ridiculous? It's not out of vanity or anything. I am saying this that it is ridiculous, but um, that's a fact. In fact, It's a fact, and it's a classical case of comparing apples to oranges. Gravity represents apple, and let's say if photon, the quantum gravity represents orange, then we are comparing and trying to unify apples and oranges. Right? However, there's a big however here. However, if you want to, if you want to uh, call this, I call 10 squared, 10 raised to 4, 10 raised to 6, 10 raised to 8, up to 3 times this. Let's say what? Yeah. So, however, if you want to call this guy, which I call magneton, because that is the force carrier for magnetism. So, if you want to compare and unify this with photon, this is photon, right? 3 into 10 raised to 8 particles is photon corresponding force carrier. Let's say this is gluon, this is let's say weak boson or something. This is a Higgs boson. Let's say critical type. So all of these, if you want to combine, unify, they're already combined. If you just want to find this, that's a different case. If you want to call this graviton, which is it is not, this one, you can go ahead and try to unify this. Okay. So just leave a comment if uh, we can unify uh, quantum and electric works. Okay. Uh, I kind of rushed my case. Come up with comments telling whether it makes sense to compare graviton with what, I mean, trying to unify. This, I don't have any objection. If you want to unify this magneton with weak boson, itself is weak boson, I think, gluon, Higgs boson, photon, this is medium, this is strong, this is Higgs, this is weak. Okay. So, they already is gut, this whole thing is gut, and the medium is this one. There are four fundamental forces. And medium, strong, weak, gravity. Yes. All the while, I have been telling the same thing for past 15 years or so. What gravity is for relative world, yeah, Magnetism is for quantum. I've been telling, I wrote a book in 2010, way back in 2010. Even then, I had the same idea that the movement network, but it's a child like enthusiasm. But this is far more mature. So, yeah, you want to compare? Then gravity is what photon is for quantum, graviton is for relative, and mass, what mass is for relative. Right? Charge, charge is for quantum. That is the reason why you have electrical flux is equal to 1 by 4 pi square Q1 Q2 by R and epsilon. So, uh, the same gravity for gravity also I derived similar equation 4 pi r squared into 190 uh, into 10 raised to 7 into mn by mn. Basically r squared is 4 pi r squared 4 pi r squared is q1 q2 by epsilon naught. This is mm by 190 into 10 raised to 7. So that's why they are very similar, aren't they? So that is my case. Let us meet some other time. For now, we'll call it today. Thank you very much for watching the video. It's